You made it to the final. You demonstrated not only your skills at technology and science, but also your empathy and your motivation for helping others.
We know that you've done your states and your schools proud.
I know that you have put in a lot of hard work into this. All the best for your pitch presentation. I know that you all are gonna rock it.
Good luck, have fun, and I'm rooting for all of you.
I'm wishing you the best of luck.
I am wishing you a lot of luck.
Good luck.
Good luck on your presentation. You guys are going to do a great job explaining all the hard work that you've been doing in the last couple of months.
I want you to remember that you are powerful. You have the power and influence to make the positive change, not only in your community, but in the world.
All right, welcome everyone to the 2023 Solve for Tomorrow National Finalist Pitch Event. We are so excited to have you all here. My name is Angie Adams. I'm a senior manager on the corporate citizenship team at Samsung Electronics America, and I have the lucky privilege of being one of your co-hosts for today.
And I'm Kevin O'Hanlon. I'm Senior Director of Government Relations based here in Washington, D.C., and I have the pleasure of being Angie's co-host for the day.
And we are so excited to have you here. We have our 10 national finalist teams from 10 states all around the country. 10 incredible teams means that we're going to get to see 10 amazing projects that all use science, technology, engineering, and math to solve some of the greatest challenges in our communities today.
And for those of you who have joined us in previous years, you've seen a number of our different office locations, but we are very pleased to welcome you to Washington, D.C. this year. The D.C. office is home to a number of teams. We have our government relations team, public affairs, business to government sales, as well as our intellectual property center. And we're so excited to have you here in the nation's capital for this final event.
And we are excited to be here. It's a gorgeous space. We've got lots of great TV screens around with all of the great branding on it, so make sure you take a look around. At Samsung, our guiding vision is Together for Tomorrow, Enabling People. And while Solve is focused on STEM, at its core, it's really about humanity. And this is my first year as part of the Solve for Tomorrow family. And I spent some time looking back at all of the work that you all have done over the last several months, and I was blown away. The level of creativity, of intelligence, and really of empathy that you all infuse into your work is truly inspiring. And you all, of course, are already winners. Every team here has already won $50,000 for their school, so great job. And since 2010, Samsung has awarded more than $24 million in Samsung technology and classroom materials to Solve for Tomorrow winners. And since 2018, we've been working closely with Donors Choose, enabling us to equip classrooms around the country with the technology that they need, with the tools that they need, empowering teachers, engaging communities, and changing lives. We are so proud of this partnership with Donors Choose, and I'm incredibly honored that we have a featured guest speaker with us today from Donors Choose, the CEO of Donors Choose, Alix Guerrier. Yep. Alix is the CEO of Donors Choose, the leading nonprofit for supporting U.S. public schools. Prior to Donors Choose, he was the CEO of international charitable giving platform Global Giving and co-founder of LearnZillion, an education technology company that was acquired in 2019. His previous work experience includes consulting in McKinsey & Company's education practice, teaching middle school and high school mathematics, and working in the public finance department at Citigroup. Please join me in welcoming Alix.
Wow. Thank you. It is such a privilege to be here and to be a part of this event, welcoming teams to this 13th Samsung Solve for Tomorrow event. Welcome to lovely Washington, D.C., my current hometown. We're so glad to have you here. And congratulations. First, I know that folks are watching online as well. Congratulations to everyone who participated, and especially congratulations to everybody in this room, all you finalists. To have gotten here is an incredible achievement, so you should be so proud of yourselves. I know that you are. growing up, I always wanted to be a scientist. For most of that time, an astronomer. I ended up majoring in physics, as a matter of fact. My wife, to this day, still jokes that early on, when we were getting to know each other, and she asked me, "Oh, so why did you choose to major in physics?" And I was kind of dumbfounded, and I answered, "Well, what else would I have majored in?" Which she thought was hilarious. And so as a science and math kid growing up, and as you heard, I also taught math and science, sixth grade math and science, in high school math. And so just being here with all these STEM minds with tables full of Legos, like this is truly my happy place, so I feel awesome to be here. Growing up, I would have loved to participate in an event like this. If you think about all of the characteristics of the process and this program, they include creativity, research, obviously rigorous research, teamwork, ingenuity, social value, practical application of what you're coming up with, mentorship here and at your tables. Like all of those ingredients put together are a recipe for an amazing learning experience, really the ideal learning experience that we'd want for all kids. And so that's why we're so proud at Donors Choose to be a small part of this and to be a part of supporting the work of Samsung. Actually, I was reminded this event has a special place in my heart because last year, I actually joined Donors Choose just about a year ago as CEO. And the event last year, which Anne remembers, was sort of my first external event in that new role. And I remember sitting back in the audience, our Chief Revenue and Marketing Officer, Katie, was with me, and we were watching some of the presentations, and sort of we were flabbergasted because we were watching these incredible presentations saying, "Oh, wow, that one's a natural marketer. Oh, look at that analysis. Born salesperson," thinking that we would be so lucky to hire any one of the folks who were up on that stage. So here's a pro tip for you. Later on to the kids presenting today, when you're applying for jobs, make sure to put this on your resume because it counts for a lot. So I also want to say a word to the teachers in this room and also online. Thank you so much for being a catalyst for this incredible learning opportunity. Teachers are the community that we most directly serve at Donors Choose. We certainly aspire to do so. Every year, we survey our teacher community to learn what is it like to be a teacher now. And here's the short answer. It's tough, and it's getting tougher. If you think about all of the expectations that we place on our educators, not only the content, but also being social supports to kids and keeping up with technology and sometimes political battles. It's getting harder and harder. We also know that passion still prevails. A large majority of our teachers would love to stay in the classroom for 10 years or more if it's sustainable. And so I think that's a part of our job as a broader society to work to make that work sustainable. We're trying to work on that at Donors Choose. It's a big solution that's required, but also programs like this are part of the solution. That is, programs that support teachers in what they care about the most, which is helping kids learn, and in fact, in this case, really bringing to life the hugest, most ambitious, most socially important ideas that kids have. It's incredible. Again, I'm really proud to be a part of this. Let's see. I think I also have just a little bit of advice for the students who'll be presenting today. Here's this very, very critical, important advice. You don't need advice. That's my advice. You've already done the hard part. You've already done the work of actually crafting your ideas, bringing them to life, the research, the prototyping, even the rehearsal for today, which I know probably has been pretty intense. All of that is behind you. And so now you're at the end. now's the time just to enjoy it. So when you're up here, even in front of these somewhat intimidating folks, make sure to take time to savor the moment. Take a deep breath, slow down, and enjoy the ride because you've already won. So that's what I want to say. Also, I just want to say that down the line, after college, when you're looking for a job, think about Donors Choose. We hire a lot. And with that, I will say congratulations. So round of applause to everybody in this room.
Thank you so much, Alix Guerrier from Donors Choose. Alix, we know you're on your way to your own event back in New York City today, but we thank you for being with us today. And again, we're so grateful for the partnership between Solve for Tomorrow and Donors Choose. So thank you, Alix. Now, let's meet our esteemed panel of judges.
All right, but before we meet our judges, am I working? Oh, there we go. All right. I just want to say thank you to everybody who's joining us today, both in person and virtually. I know we've said it a lot this morning, but it means a lot that you've made it this far, and really want to make sure that you take a moment and really realize that all of you are winners at this point in the competition. And I want to thank all of the students who have participated, all of the teachers, all of the parents, the family, and the support network that you have watching us today, be it, again, here in person or virtually.
Absolutely. Thanks to everyone back home who helped get you here. All right. Now is it time to meet our judges?
Now it's time to meet the judges.
Okay. First up, we have Gary So, Vice President of Marketing for Digital Appliances at Samsung Electronics America. Fun fact about Gary, when he was in high school, he helped start his school's first recycling program, so he is in good company here. Gary, we know that it's your first year here with Solve for Tomorrow, so I want to know, what are you most excited about for today?
Well, I think is this on?
Oh, we need these mics on. Yeah.
I think the most, some of the challenges that we face today are actually solved in different ways. I'm really excited to see how you approach the problem solving and what fresh ideas you have. So I'm excited to see all the different projects. Congratulations to everyone. You've done a great job.
Thanks, Gary.
Thanks, Gary. Next up, we have Kim Swanson. Kim is the Vice President and General Manager of the T-Mobile account team for Samsung, based in Seattle, Washington. I think you traveled the furthest to be here, so thank you. We appreciate it. In high school, Kim was part of the student council, serving as class president and treasurer. So, Kim, we know you give a lot of presentations as part of your job. What's the one piece of advice you have for students today?
Well, Alix kind of stole what I was going to say, but I think it always just helps to take that big, deep breath, kind of calm yourself, and just speak slowly. I know there's a lot you're going to want to say, but just be clear and precise and take your time.
Thanks, Kim.
That's great advice. Next up, we have Mr. Harry Preston. Harry is a computer science teacher at Green Street Academy in Baltimore, and also a 2022 Samsung Solve for Tomorrow National Finalist. In high school, Harry was quite the athlete. He participated in football, wrestling, and track. So Harry, I know that you were here last year, so I'd like to know what words of wisdom you have for these students once they go home, once they leave the competition today.
I would say that take every opportunity to continue your projects as far as you can, and then keep innovating, keep dreaming, keep thinking, and always keep your goal in front of you. I mean, if you put it in the back pocket, it's going to stay back there. So keep it in front of you and keep dreaming, keep pushing, and keep innovating.
Thanks, Harry.
Thanks, Harry. I have the great pleasure of introducing Paula Labby. Paula is from Great Bridge High School in Chesapeake, Virginia, and also a 2023 national finalist, or national winner, excuse me. Paul's currently the electronics and robotics teacher at Great Bridge, and in high school, Paula was the chaplain for her school's DECA club. So, Paula, what do you remember most about last year's competition?
How fast it goes by. It's just super fast paced, but take a minute, enjoy it. This is a once in a lifetime experience, and get as much as you can out of it, and enjoy all the opportunities it presents for you in the future. You don't even realize how much this is going to impact you going forward. So take a minute, appreciate it, and thanks for being here.
Thanks, Paula. And rounding out our esteemed panel of judges, we have Kiki Huckabee. Kiki is the Chief Impact Officer at MindSpark Learning. MindSpark is an international nonprofit that works with education entities to develop strategic plans to solve their biggest problems of practice. And back in high school, Kiki was a competitive dancer. And Kiki, I know that you work a lot with STEM educators, so I'd like to know, for the teachers here in the room and the teachers listening back home, what's a big piece of advice that you have for them?
I think my advice is just probably everyone already knows here is keep believing that you have the power to make change. You are all here because you're doing that. And so keep knowing that you can make impactful change in your community. You don't have to wait to do that. You can do that right now as you are.
Thanks. All right, welcome judges.
Welcome, judges. Now, we're going to invite our first school up, but before we do, just a reminder for everybody, the schools have 4 minutes to pitch their project, followed by 6 minutes of Q&A from the judges. And with that, Angie?
We have Greenbrier East High School from West Virginia. Welcome to the stage.
Imagine this. You start out on a caving exploration journey with your friends. You begin feeling excited and ready. Then suddenly, things take a turn for the worst. You get down there and you begin to look around. You suddenly realize you're lost. You sit down on one of the cave rocks and begin to make a plan for the worst. When suddenly, a bright light flashes across your face. You realize it's a group of cavers who have stumbled across you and your friends. They help you out to safety, and you're so grateful for them. But you can't help but wonder what may have happened had they not found you. Would you have made it out? Could you have made it out? Well, luckily for a group of cavers in Richmond, Virginia, they didn't have to find out the answer to these questions, thanks to a change of plans made by expert caver Ed Swepston. Hi, I'm Olivia Warfield, and I'm a member of our media team.
I'm Nate Smith. I'm head of fabrication.
I'm Abby Warfield, and I am research lead.
So there are approximately 45,000 caves in the United States. According to the latest cave census done in 2008, there were over 4,700 recorded caves in the state of West Virginia. Now, Greenbrier County, where we're from, consists of about 1,200 caves, making up a fourth of the entire state's cave system. Now, on a national recreational scale, there will be about 2 million Americans that go caving each year. Of those, 15 will be injured and 3 will die.
With these statistics in mind, a group of dedicated engineering students, including myself, decided to take on this problem and design a device that would aid in cave rescues. We came up with the Digital Junction Tracker, or DJT for short. The device consists of 3 units: a hand unit, which will stay on the caver at all times, a ground unit to be placed at the entrance of the cave, and up to 1,000 breadcrumbs to be placed sporadically throughout the cave. Cue the video. These devices run on low-frequency radio signals. Each of the devices will have their own radio signal. The hand unit will have the highest signal. The breadcrumbs will have numerically descending signals, and our ground unit will have a signal of 0. When a message needs to be relayed from the hand to ground unit, the hand unit will lower its signal to match that of the final breadcrumb. This will set off a chain, and the rest of the breadcrumbs will begin to lower their signals as well, finally reaching the last breadcrumb, which will drop down to a 0 to match that of our ground unit. This will allow communication between the hand and ground unit to occur.
So how these are made? We take all the components of the DJT, consist of a microprocessor, batteries, and LED screens, different things, LED lights. They go to a soldering team. They'll assemble them, do the wiring, all the soldering. Once they are assembled and functioning, they will be sent to fabrication. Fabrication will 3D model cases and 3D print them. Then they will also assemble them. From the beginning of the project to now, we have redesigned these cases about 15 times.
While designing our cases, we had several factors to take into consideration. Our biggest focus was on making sure these devices were as sustainable and eco-friendly as possible. We found a company that uses biodegradable packaging, creates biodegradable filament, and plants a tree for every spool of filament purchased. We also had to decide on which batteries we were going to use. We wanted to choose batteries that had very little impact on the environment, so we chose lithium-ion batteries. With all of this information, any questions?
So Nathan, Nathaniel, you mentioned that you had to kind of fabricate it and design it 15 times. What kept you going? Because certainly I would have stopped at 3 or 4, but what kept you going after the 15 times?
I mean, just the want to perfect it. I mean, there's a lot of work that has to be done that goes into this. You know, it's just good. You see progress, and you know you can get it to work better, and you know it's just motivation. It keeps you know it can work better, function better. So you get to that point, and then you see things that can be improved. So you improve it, and then there's more. It's just an ongoing thing, and it's really been a cool thing to work on.
Well done.
Have you given it any thought to how the cavers will carry the 1,000 breadcrumbs into the caves?
So as of right now, our crumbs do have quite a bit of space that they would take up. At the moment, we're currently working to downsize them. When cavers normally do go in, they have a set of things that they have to carry, so they would likely be held in the backpack in a small case that they would all hold. But like I said, once we do perfect these, they will be quite smaller and more convenient to carry with them.
And have you all looked into the cost of what this would be?
Yes, at the moment, a set of these production-wise is around $159 to make. However, throughout our process of designing these, the microprocessor that we use has had some price fluctuations. It started out as the microprocessors were $14 a piece. They then went up to $79 and have now dropped back down to $38. However, as we continue this project, we're looking into making our own microprocessors in-house, which would significantly decrease the price.
Was there consideration placed into the possibility of if a breadcrumb was moved from within the chain, and if the additional interference from the increased distance between the breadcrumbs would make a problem, create a problem?
At the moment, we can get breadcrumbs placed about, 40 feet, 400 feet? 400 feet apart before there's a problem with communication. We are working on trying to further that distance, but if it should only be moved a little bit, it wouldn't affect much.
What solutions are out there right now? Since I'm from Seattle, I don't know a lot about caving. So like, what do people use to prevent getting lost today?
So the current solutions for caving, cavers will often use things such as yarn or glow sticks to mark their path. Obviously, they can be moved and tampered with. Glow sticks will lose their light extremely quickly, and they won't be able to follow their way back. If there's any sort of animal, obviously the chain of yarn can be moved. Also, these have a significant environmental impact. Another solution that they do have, but this is only for commercial and pre-explored caves, is there is a app that will tell you if there's any damage in junction rooms, but that is only for commercial caves, like I said. So there's nothing for more wild caves that is currently on the market.
Any more questions from our judges? All right, let's give it up for Greenbrier East High School. All right, great job, guys. And while our next group is coming to the stage, Kevin, I would like to know, have you ever been caving?
No, and after that presentation, I'm not sure I have any desire to go until the solution's in place. So until then, I'll avoid it.
Yeah, me too. But it's nice to know that if we do go caving, there are young minds who are thinking of how to keep us safe.
And I love the unique solution for someplace like West Virginia, where caving is such an integral part of the community. I can't say that living outside of DC that we have much opportunity to go caving most of the time, but that's, you know.
You could go down in the metro. Maybe you could get lost in there, right?
That is true. That is true. I do feel some days like I need an app to get out of the metro.
That is true. Someone should design that. Maybe one of these kids. All right, let's welcome to the high school Liberty Avenue Middle School from Brooklyn, New York.
Good morning, I'm Cynthia.
I'm Chris.
And I'm Alan. We are Liberty Avenue Middle School. In honor of Mental Health Awareness Month, we want to tell you a story, a problem, and a solution. Wait, where's the clicker? Sorry.
Just 2 weeks ago, on May 1st, a 30-year-old African-American man named Jordan Neely, known for impersonating Michael Jackson, boarded the NYC subway cart. He appeared to be having a mental health crisis. He was screaming and yelling, saying that he was hungry and thirsty, and didn't even care if he went to jail or died that day. A passenger in the cart named Daniel Penny put Neely in a chokehold for 15 minutes straight. He died minutes after.
That's why we created SubSave.
Our SubSave prototype is created using little bits. We attached a wireless transmitter. Take it off. We attached a wireless transmitter to 3 LED lights, which are then attached to 3 buttons. Currently, the MTA has 2 buttons, red for emergency and a green for information. We want to upgrade this model and add an additional yellow button to represent mental health. We also want to petition to make the yellow button green because, as you know, currently the green button represents information, but worldwide, green is the official mental health color. But basically, the yellow button works, but when you press it, it will go to the MTA main help command to contact mental health agencies to come de-escalate the situation. Currently, NYC well handles all situations.
The MTA suggested a low-cost, efficient way to implement our sensor, but we believe and still have a prototype that will allow more access for riders or the commuters facing crisis.
Just add on to it, right? It's in terms of the idea, right? So you have button 1, button 2. Let's just add button 3, and that helps with the mental health capacity. If I'm wrong. Correct.
But with the MTA suggestion, they only have 3 help points per platform on each subway station. That's why we have our original idea where we add a transmitter, where we added electronics transmitter to the signs on the posts on the platforms, and there are about 12 to 15 posts per platform, so this will increase the user accessibility. But after more meetings with the MTA and more incidents happening, we realized there was a need for this type of sensor to be placed in the subway carts. As you can see, there's already a established intercom, but like the first location, we want to add an additional yellow button so like situations like Jordan Neely's story, like it could be de-escalated. With our app, the app will be a mobile version of our device. It has 2 parts. One that's strictly for mental health and one that's directly linked to the device. The awareness allows the users to access important information about mental health, including how it appears, how it may affect people, and how to seek help. We have important telephone numbers, links to mental health counselors, and it's directly connected to the sensor.
The alert part of the app works when the user presses the green button. Users can choose whether they want to send an incident or in a report, giving responders specific details about the crisis. Commuters even have the option of remaining anonymous, and GPS technology allows specific post locations to go to authorities.
When it was noticed that Jordan Neely was acting in a horrendous and aggressive manner, like yelling or screaming for food or throwing his jacket on the ground, SubSave had the resources for commuters to identify different triggers and behaviors that Neely was going through a crisis. Some passengers could either de-escalate the situation or press the alert system, which would then contact mental health professionals.
Jordan Neely needed help, and so many other people. SubSafe doesn't need to be placed in the subway. It can also possibly be upgraded to be placed in bridges, tunnels, buses, and much more.
Thank you. Any questions?
So this is a fantastic idea. I actually use the subways pretty much every week, every day. So great idea. Let's assume that you want to take this forward. How do you get the word out so all the passengers on the subway know about SubSave, that this is something available, and how to use it, and train everyone to know about SubSave?
We've been on the news and we explained how SubSave works, so we are working on to spread awareness about mental health and about SubSave, so more people know about it and they know they can use it if they're feeling in an uncomfortable situation or they are a part of the uncomfortable situation.
Have you all looked into response time? If someone uses this, how long would it take for someone to actually get there? And then what might you do about kind of false reporting?
With false reporting, we're still working on that, but then with response time, the MTA already has like police officers in the subway stations, so they'd obviously come, and then more people would also come during that time while the police officers are already de-escalating the situation.
How did you guys develop your app? What did you use to develop your app?
We used MIT App Inventor, which allows you to use block coding and drag and drop things to like design the app and stuff.
Were there any thoughts about sustainability that you...
We realize this is sustainable because, as you know, millions of New Yorkers use the MTA subway, but then with like these situations like Jordan Neely happening, they start to feel uncomfortable using the MTA. So if we do this, it helps more people to come back to the MTA instead of taking cars, which is a major problem with like pollution and stuff. So if our device helps more people feel more comfortable while taking the MTA, it reduces the amount of cars being driven.
I may have missed it. By the way, awesome job, guys. Did you already reach out to MTA about supporting your project?
Well, yeah, because when they came to the news, they were supporting us, like the MTA president. He came and they showed us their own version where like it's on the pole. And they brought it to our school, and they demonstrated how we could probably implement our device into theirs.
Like adding on to what Chris said, like when we had our like second meeting with the MTA, like as you saw in the video, we were talking, and then they mentioned we should just add an additional button because of cost-wise.
All right, any more questions from our judges? All right, give it up for Liberty Avenue Middle School.
Angie, that was great. I think that's something we can use here in DC as well. We've got a not quite as complicated or comprehensive metro system, but I guess, would you rename it for the DC market? SubSave? We call it the Metro here in DC, not the subway.
Metro Monitor?
Metro Monitor, there we go.
We'll get these kids.
You got to think about branding for different markets here.
Yeah. I love that the president of the MTA actually went to go visit these kids. I mean, that's the power of this competition, right? Like, you guys you're so young, and yet you have these big city officials coming to, or that are interested to learn about your ideas. So definitely keep it up. It's pretty impressive. All right, we have our next group coming to the stage. We have Brandywine High School from Delaware.
Hello, we're the team from Brandywine High School. We'd like to start our presentation with a trip to a classroom that inspired us with this problem. This is Frank Hughes' classroom. Mr. Hughes is a physical education teacher who specializes in students with severe cognitive and physical disabilities. Let's take a minute and look through some of the details in this scene. This is Mei Ling. She's playing baseball. As she reaches for this assistive button, it connects to this interface box to turn on a corded leaf blower, which then launches a ball to simulate her getting a hit in baseball. Notice that around the gym there's more systems like this that are connected to more devices for other students, and they all use this same type of interface box. Let's see how this core component works. It connects to an outlet in the wall for power. It has switches to allow you to control the function, and there's outlets for you to plug in any household device. There's also an aux connection to allow you to plug in an assistive button like the one Mei Ling was using. These buttons are designed for people with all ranges of mobility. This is a fantastic product, but it's $300. Mr. Hughes' classroom is able to afford these, but when students go home, the cost barrier prevents them from engaging in the same activities outside of school. Last academic year, using our skills in digital design, precision fabrication, and physical computing, we created low-cost alternatives, and we tested them in real-world environments with other students in our district.
But the problem we failed to realize was the impracticality of manufacturing our devices on a scale that would meet real-world demand. So let's do some quick back-of-the-napkin analysis. So taking into account the number of students with special needs in our district, we made a short-term goal of about 1,000 units. Accounting for all of Delaware K-12 population, we've set a long-term goal of about 10,000 units. But there's actually even more. So while presenting our project at the University of Delaware last fall, we met Diane Massey from Kendall Senior Living. She helped us explain to us that our product can extend beyond just those students with disabilities. As she told us, all of us will one day gain some sort of disability at some level. And it's important that we have products like these so that we don't have to give up that healthy, active, and engaged lifestyle. So with this in mind, we realized that we now had to incorporate the 6.4% of Delawareans that have independent living disabilities, leading us to our stretch goal of 360,000 units.
So we had to go back to the drawing board to address this problem of scale. We used more commonly used components to drive down our cost and created a printed circuit board for our electronics. We can now tap into the highly efficient world of PCB manufacturing to get a high volume of PCBs for a low cost, like so. We needed a robust enclosure, so we turned to leftover PVC. Over 7 billion pounds of PVC are discarded each year, so by upcycling it, we hope to reduce its effect on the environment. To help us with our lofty goals, we partnered with the SITE program, an established manufacturing program that helps young adults with special needs gain skills and confidence. So let's recap. First, our device is a seamless substitute for the interface box, so current systems will be easily replaced. Second, our transition to mass manufactured products allows us to make it for less than $10, a 97% reduction from current market products. And finally, our transition away from 3D printing, soldering, and coating allows for an easy assembly. So thank you for helping us share our story and helping kids like JoJo make more home runs.
So can you explain a little bit more about when you press the button, it's basically like turning something on, or what is it actually?
Yeah,
do?
so we have it right here. You can just press and there's different modes. So you can leave it on pulse. So you can like hold it and it'll stay on. You could go to toggle. You press it once, it stays on. You press it again, it turns off. Or you could go to timed. So on the other side, there's short, medium, and long. You press it and it stays on for however long the time is.
Yeah, and so these modes are really useful because you can use it in all different sorts of applications. So one common application is like they use it when they're trying to cook things. So like imagine using a blender. Lots of times you just want to pulse the blender. So an example like this direct mode where you have to hold it is more useful. Whereas like if you're just turning on a light to like look at something, this is much more useful. And then lastly, like a time mode is just for some things that need to be timed. Like oven, yeah, exactly. And it's often also commonly used in special needs education because like sometimes they want to like teach people cause and effect reactions. And so by teaching them like, hey, if you touch this button, this will happen, that really helps them with their development. And also, like we mentioned that this is really helpful when you get home, but it's also useful in the classroom as well. By transitioning to lower cost devices like these, like 97% reduction, that frees up their budget so that they can buy new, better things for their students to help further engage them and enhance their development.
Can I ask you if you had to take this one step further? So some of the appliances that we have are actually, they have variable speed. Right now you have an on and off switch. On basically it's 1 or 0, binary kind of control. How would you adapt it so that you could have variable, meaning it's a temperature control from 0 to 50 to 100 to 150, or perhaps some measure of like illumination in this light, meaning going from dark to low dim to high dim to full brightness? How do you adapt this this device to kind of control for that element where there's multiple layers of output?
That depends on how the output is actually controlled. Because the way our product works right now is just simply switching power on and off via the relay. So the problem with like changing the AC current that's flowing to that is oftentimes devices are specified for a certain voltage. So if you change that voltage, you change the current, the device will malfunction. But if there's like certain outputs on the device that we can interact with, then we would be able to maybe change modes like that.
So as an electronics teacher, I'm interested in your PCBs. How did you guys design your schematic and your PCB? How did you set your requirements?
So one of the reason we went to PCBs, one is that it's super easy to manufacture now, super cheap to manufacture, and the low form factor too, so it's so small. But also, so one of the big criteria really was that how small it had to be. And so we used Easy EDA. So it actually partners really well with this PCB manufacturing site called JLC PCB. And so together with that, like we were able to get these within like a week. So we worked on our schematic, like figured out exactly what we wanted to do, and then we could order and get it within a week to test. And so one of the things I think we talked about a bit was we went away from microcontrollers. So that's what we had last year, but I think as a previous group mentioned, they're actually pretty expensive. Like the ones we were using were about $10 to $20, and our product now comes to $10. And we realized because lots of it was simple logic, and we realized if we just used electronics like 555 timers and resistors and capacitors, we could actually simulate that behavior for a much lower cost. And it also simplifies the assembly process, because at this point our assembly process is pretty simple. It simply consists of getting those PCBs. You just screw in the wires with a simple screwdriver, and then you place it in the housing. That's it.
Currently, I know that's set up for specifically to have two-person like manipulation, right? So the person who sets the tone or pulse or off or on how it's done is one-sided or ability to the individual. And the other is for the person who has the disability. Was there consideration of making it so that the disabled person has the ability to change settings, and also have you consider different input other than the button?
Yeah, so in our original design, we were working with special educators, and in that situation, they would be the ones setting the different modes. But it's essentially just a switch. Like it would not be difficult to put in a similar button that someone with a disability could use and do it entirely on their own. Also, the way we're controlling it is with this button. A lot of companies that make technology for people with disabilities make other ones. So there's one that's a touch sensor. So if you just put your hand on it, it can work like that. Or there's ones that like detect eye movement or like motion sensors, similar things. It's really like, it's for a range of people with all kinds of different mobility and different skills. So it's kind of for everyone.
Yeah, it's like super easy to swap it out. It's just an audio jack connection right here. So you just unplug it and plug in whatever sensor you want. So they're wireless ones too, everything. So whatever the student with disability needs or the individual with disability needs, you can connect the appropriate sensor and customize a setup for them.
All right, thank you, Brandywine. You know, one of the things I love about their solution is that they made it affordable. I think so often some of the technology that people need is inaccessible, right? So if you have a disability, yet you're disadvantaged to be able to afford the solution that you need, I think these kids came up with a great solution for that problem.
Yep, absolutely. And I think I can say for sure that when I was in high school, I was not talking about printed circuit boards.
Yes, yes.
That was definitely not on the menu, so I'm impressed just by the very concept of it, much less the execution.
I know, some of these judges' questions, I'm like, wait, what does that even mean? So these kids are definitely very, very smart. All right, we have coming to the stage Porter High School from Porter, Texas.
Oh, this is an
All right.
intricate setup
A
here.
lot of assembly
Yeah.
for this one. Looks like we have some fruit, some bugs. Do you guys need a hand? You okay? And we have an injury on the team too, so.
They also were one of the last teams to get in last night, so
Yes.
we're very impressed with the coordination this morning.
We had some flight cancellations, I think a midnight arrival. There was a plane, a train, several Ubers, but yet they made it here. And they're awake, so they deserve some credit for that. Do you guys need a hand?
It's like a science fair project. It's,
Wow, funny, funny. It's a science
know,
fair
yeah.
project. This is sort of like a science fair. It's very fitting. Okay, clicker. All right, take it away, Porter.
Our bee population is declining. Every single day, millions of these crucial insects die. 150 varieties of fruits and vegetables, such as the one seen before you, gone. In fact, bees are responsible for pollinating about 75% of the world's crops. Recent news articles in our community have reported 2022 to be the worst year in terms of beehive health. Our Houston area beekeepers have lost a total of 50% of their hives in the recent February freeze alone. In order to stop this and save our food and the bees, we had to find a solution.
Introducing HiveHub. HiveHub is a beehive monitoring system that collects live data from inside the hive and displays it on the web and a user-friendly app. This solves one of the biggest challenges in beekeeping, when beekeepers arrive and find dead hives. We experienced this issue firsthand while touring one of our local beekeepers' hives. When he arrived, he found 2 dead bee colonies that could have been prevented if he had HiveHub. The reason he couldn't check on these hives more often to save the bees is that each time a beekeeper checks on the hive, it completely resets its natural balance. So the bees have to work for 24 hours to reset this hive to its original state. HiveHub will not only allow for the bees to remain undisturbed, but for the beekeepers to have an instant access to all of their hive activity, anywhere, anytime. And by uniquely utilizing AI, HiveHub streamlines this process to a level never before seen. With a single tap of the AI checkup button, HiveHub instantly reports potential issues and showcases faltering and flourishing hives. This innovation effectively replaces time-consuming, harmful bee inspection practices with not just the ability to see sensor readings, but the ability to have an almost instant analysis of all of your hives.
By applying STEM, we created Hive Hub utilizing a microcontroller with temperature, humidity, VOC, and 4 sensors. The circuitry for the device is placed at the topmost critical part of the beehive, right above the brood frame, in order to allow for the most precise sensings of both temperature and humidity. The device is also vacuum molded into a recyclable plastic shell to reduce bee disturbance and destruction. This guarantees that our sensor can accurately transmit information to Adafruit.io, which then transport it to our mobile app. The app and raw data also works in real time. For example, if you blow a humidifier onto the device, you can see the change in temperature and humidity on the dashboard in front of you. Additionally, when researching small hive beetles, like this one, we found that when they infiltrate a hive, they ferment honey. So by putting an alcohol rag onto the device, we can see that the check mark turns into a beetle to indicate that there's an invasion happening. Finally, we know that honey production is key to many beekeepers, so we included a force sensor that accurately tracks the weight of the hive over time, which should increase by about 7 pounds per day in prime honey season. This ensures, alternatively, if the weight is decreasing significantly, that indicates to beekeepers that there's a serious problem in their hive that they need to check up. This guarantees that beekeepers will be able to quickly and efficiently check on their hives without interfering with the bees, and also proves our feasibility.
Our product has already proved its effectiveness in our community. We interviewed the head of the Montgomery Beekeepers Association, the head of the Montgomery Area Beekeepers Swarm, the owner of Big Thicket Beekeeping, and lastly, one of our very own teachers, Mr. Fortenberry, who maintains around a dozen beehives. All of these beekeepers strongly agreed that our product would greatly assist them in their day-to-day life by allowing them to have easy access to information about their hives anywhere, anytime. And we don't just save the environment by saving the bees. We also use recyclable PLA filament and vacuum-formed recyclable plastics in order to reduce waste. And one of the best features of Hive Hub is that it exclusively uses solar energy and has 0 carbon emissions, saving 4.4 kilowatt hours. This is equivalent to 379 smartphones charged per 100 hives. This confirms that Hive Hub will have a positive impact on the environment, saving the bees and our ecosystem due to our commitment to environmental sustainability. In the future, we plan to expand across Montgomery County. With the help of community partners, we have already begun implementation of our devices into hives, planning to reach over 250 hives in the coming months. This will save a resounding 2 million bees. We then hope to expand across the state, the nation, and beyond, saving millions more. Hive Hub, saving the bees with ease.
Or actually, Carmen can. She's not broken. Okay. We're going to give you little miniature hive hubs that you can look at. It works just like the real one, except it doesn't show weight. And you can blow on them and look at the temperature change and the humidity change and check them out. I also want to add that I think this disconnected from my phone hotspot, so none of the numbers really changed, which I apologize for that. All right, any questions?
Great job. You mentioned your thing about expansion geographically across your state and obviously possibly across the country. Curious if you've thought about other applications of this sort of sensing device where you can maintain a optimal environment for other types of animals or perhaps other types of products.
That's a really interesting question. I've never really thought about expanding past bees. I mean, now that you say that, there are a ton of different places that we really could put this in, from different factory conditions to even maybe mining conditions, since we have these VOC conditions. But that's a really interesting question. I've never really thought about that. That's a good thing. We could really expand in new branches besides bees.
Fantastic.
How much does it cost to make these?
Okay, so our cost wholesale is $53.53, and we plan to have it open source so that anybody can go and look at what materials that we used, and so that they can build their own and implement it into their hives. And then we're going to expand into local bee stores and sell it at wholesale cost.
That price is actually super low compared to our competitors. One of the top competitors in beekeeping, they charge about $75 just for temperature and humidity alone, and we have way more than that for a much cheaper price.
And I want to add that competitor he's referencing is Broodminder, and the thing about them is that in order to even check on these hives, they have to go out there and connect their phone to the Bluetooth from their little sensors. But we're not only doing this across the web where they can check it anywhere, we're also using GPT 3.5 Turbo architecture so that we can use AI to just instantly give them all of their hives. So the average beekeeper has around 11, 10 hives. So with them, they'd have to check each individual hive to even find a problem, and they have to go out there. But with us, they can do that literally anywhere that they have an internet connection and have an instant analysis where the AI will tell them that these hives are doing great and these hives may have some problems. Which you can go to this slide if you want to
Now this is an add-on to an existing hive. Has there been considerations to have the hive boxes be already integrated?
This is an add-on. The thing is, a lot of these beekeepers already have these built hives in their thing, and there are growing beekeepers in the community, but our product is super, super easy to add to an already accessible beehive because it's really just sticking this to the side, putting the solar panel on the top, and the only thing that goes in is one wire with this vacuum seal thing above the brood frame, and that's kind of where like the queen lays all her eggs, so it's the really important part of the hive, so we just get that part sensed.
So I know the colony collapse disorder is a problem that's plaguing a lot of beekeepers. Do any of your data support monitoring that phenomenon?
So a lot of colonies are actually lost to a lot of natural reasons, and that's what we're trying to help. Because as soon as that there is a change in temperature or like a big change in humidity, we actually on our app allow for like the range that is like perfect for the hive conditions. So once these come out of the hives, the beekeepers will know immediately to go and check on them.
And I want to add on to, we live kind of in the south in the Houston, it's very humid. So one of the biggest problems when beekeeping in our area is these small hive beetles. And basically they'll climb into a hive and then they'll start killing all the bees and fermenting the honey. And that causes the alcohol, and that's why we've added this VOC sensor. But that's just one way that we're going to, because they can really just instantly, once they get in the hive, they can collapse it. So the beekeepers really have to get on that. So we can instantly notify them and help stop their hives from just collapsing out of the blue, like our beekeeper we had with Mr. Fortenberry have his two just die out of the blue.
So because these are on the outside of the hive, have you thought about ways that it won't be disturbed? I mean, I know you have a kind of encapsulation there, but have you looked into that piece of it?
Well, for this is actually kind of our display case we kind of made that showed hive hub on the side, but in reality, they would get like kind of just something you could purchase at a store that's like a waterproof big case, and they nail that to the side of the hive, so no big things. Because one of our biggest challenges with this project is we're dealing with just straight environmental problems. I mean, you're putting this in a colony of 60,000 bees. We're constantly adding propolis to everything you put it on. So we really have to vacuum seal and make sure everything's airtight. And that's kind of why our project's changed so much, as we put this in colonies and realize that our electronics are getting hurt. We've fixed that.
Okay, so you're looking in how to kind of make sure that they're secure and safe.
Yeah.
Yeah, and additionally, with the bee disturbance thing, there's a 3 ASINs rule that we learned when talking to local beekeepers, which basically states that if our device is any like taller or smaller than 3/8 inches, it's going to either be covered in a wax-like substance called propolis, like River mentioned, or it's going to be kind of chewed on by the bees in a really weird process. So, so our device is really tiny. We made sure to make it as small as possible, the part that goes into the hive, so that bees will have like no chance of actually messing with it at all.
You can actually see some of our variations, because when we first started this project, we made like this big sensor that had all of our sensors on it. But
Okay, so originally we had this big breadboard that we were soldering all the sensors on, and that's what you actually see in our video, as well as we had a Raspberry Pi on the side with where we used just kind of an open source AI thing to count the bees that were entering and exiting. But after talking with beekeepers, that took a lot of power, first of all, because the Raspberry Pi is like a whole mini computer, and we realized that that was too much power to run. So, and the beekeepers were like, we really don't need this data. Your other data is more important, especially with those small hive beetles. So we shifted, because in the past, that was our future thing, is we wanted to add this VOC sensor. So now we have that. So our product's gotten a ton smaller now. Like almost every week, we're changing and shifting it based on what the community wants and needs to make it even better for our community.
Thank you. Time. Great job, Porter High School. I can't believe these kids probably only got 2 or 3 hours of sleep, and they still gave this great presentation. All right, I think we are ready for our final team before lunch, Doral Academy from Northern Nevada.
Good morning. We are so excited to be here today. I'm Maverick Dumont, and we are from Doral Academy of Northern Nevada.
Hi, I'm Marlo Tanaka, and we're all in 6th grade. I'm Danielle FICO. Our project is a technology-based communication tool to connect the food insecure and farmers and organizations that have food in an easy way. We'll have 3 major users: the giver, the receiver, and the learner. It will start out at the learners that will turn into givers, which can help the receivers get food. What we've been doing is we've been trying to reduce the food waste, not just in our school, but also in our community. We've been thinking up ways to reduce the food. And actually, what we've been doing is we've been making an app and game. And how we've been doing it is we've been talking to all different people around our community. One of the people that we've actually been talking to is a farmer named Miss Megan. I don't remember what she works for, but she works for somebody. And she has 2 goats. She actually asked us to come visit her farm. And so what she does is she teaches people and helps people reduce the food waste around our community also. One thing that we've learned from her is 24,000 tons of food goes to the landfill per year. Don't feed the trash cans, please. I beg you, don't feed. Another person that we've actually talked to, another organization actually, is Biggest Little Pantry. What they do is they make and collect food, and then what they do is they put it into this huge pantry all around our communities. There's actually quite a few in Nevada. But we visit one and we put one in there a little. Some people put a ton, but we put as much as we could. And the last organization that we've talked to is Food Not Bombs. What they do is they cook food and then they hand it out to you at like a park or something. That's who we met, and that's what they told us. So they'll give you the food, and then if there's no more, then no more. But what they need is fresh produce, and that's where the game comes in, and app.
To reduce the methane that is produced by the food that rots in landfills, we needed an app that could be the bridge between the food insecure and those who are working to solve the problems of hunger. I wonder who thought of the name Food Bridge. From our conversations, we've learned that the food insecure generally have technology. They can go on the web and use a chat feature, but do not always have enough food. So we decided to, we've prototyped a chat feature that would let those who need food find farmers who have extra produce and organizations that teach and help the food insecure. So for farmers, that could be, for example, Miss Megan, and then I could be, for example, a member of something like Food Not Bombs. So we could go into a private chat and give each other a location and time using the map page that pins certain locations and times for meetups and food exchanges.
We also decided that we need pages for education because people do not know or understand how big a problem food waste really is in our community or in climate change itself. So the United Nations reports 8 to 10% of greenhouse gas is emitted from food that is grown but not consumed by humans. So we're making a game in MIT App Inventor that can help people learn about food waste, and then after they learn, answer a quiz on it. We're trying to get kids on it as young as possible, so that when they're older, they know how to. When they're older, they know how to use it. Like me, most people don't know what 682 net pounds of CO2 looks like. So we're also making a page to connect to visualize those extract numbers in an easier way, like the way for refrigerators.
We hope that you agree that an app like Food Bridge will help to raise awareness about food waste and at the same time tackle food insecurity and climate change in our community. Thank you for your time.
Tell us a little bit. Well, first, great job, guys. I think this is a big problem. So I like how you broke it down to think about the giver, the receiver, and the learner. I think that that's awesome. Tell us a little bit about the scalability. So when you are looking at, right now, there's a private chat option where people can communicate about where to pick up food. What does that look like when you have lots of people using this app?
So for that, we're thinking of not just having private chats, having more of a Facebook style where there's a public chat where everyone can see it. Okay. And then once you find the people, you can go into the private chat and discuss details like that.
Okay. Thank you.
So are you currently trialing this then? If people are actually using it, and how's it been working?
So what we're doing right now is it's just a prototype for right now, but we're hoping by the end of this year we could send it out into the world.
It takes a group of professional app creators 3 months to get app from prototype to working app, and we're just 5th, 6th graders. The other two are not here currently, but so it'll probably take a little more, around maybe a year. But right now we're learning how to code professionally, and we'll eventually get to that.
How would you like to spread the word about this app in your community?
So the community asked for it, so once they figure out that it's online, they should want to get onto it, but we're also hoping that some of the organizations that we've worked with will help spread the word.
This is a great idea. I think it's a problem that all cities in this country faces. Curious, you spoke to farmers. Did you speak to restaurants that prepare food that actually they throw away the food at the end of the day? And how any challenges you see in adapting your solution for a restaurant environment where they throw away prepared food versus maybe produce?
We haven't talked to any restaurants that. Oh, there we go. Sorry, I thought that turned off. But we were kind of thinking of getting more organizations to help us.
Have you put additional thought and consideration into the safety with meetups and placements and times?
So it's kind of not just like for every single person. We're planning to have like certain forms signed and know that you're safe and no one will actually get harmed, and that everyone stays safe.
Any more questions?
All right. Thank you, Doral Academy. All right. That was our 6th grade team, you guys. 6th graders are building apps. That's pretty impressive. Kevin, what were you doing in 6th grade? Were you building apps?
I don't know. I've got a daughter who's going to be in 6th grade next year, so we'll see what she's up to next year. Maybe we'll try and push the school into Solve for Tomorrow.
Exactly. It's impressive how we have kids from 6th grade all the way through high school. So great ideas from all ages. So that was our morning portion. We heard from West Virginia, New York, Delaware, Texas, and Nevada. I think we have a little over an hour break for lunch. So if you're in person, please join us back at 12:30. Virtually, we will see you in about an hour. Thanks,
All right.
everyone.
Thanks, everyone.
All right, welcome back everyone on the live stream and in person to the 2023 Solve for Tomorrow National Finalist Pitch event. I hope everyone enjoyed their lunch break. We had some tasty burgers and chicken fingers. It was quite delicious. And this morning we heard from Texas, New York, Delaware, West Virginia, and Nevada, and we've got 5 more great teams up next. So let's get started right away, bringing up Bloomington High School South from Bloomington, Indiana.
And as Bloomington gets ready, just remember you have 4 minutes to present, 6 minutes for Q&A with the judges. And here we
Hello, everyone. Thank you for being here. We're from Bloomington, Indiana, and we're so excited to tell you about our temperature mural project.
So climate change is rapidly increasing global mean temperatures, sapping billions of dollars in worker productivity, destroying our natural ecosystems, and worsening ailments like asthma. In fact, studies show that extreme heat is the deadliest extreme weather event, killing millions of people each year. And these effects are worsened in cities, where anthropogenic structures like buildings and roads heat cities more than the surrounding natural ecosystem, worsening all of the effects. And we see this in our local city of Bloomington, Indiana, where a 2018 study done by our university showed that urban areas are up to 9 degrees hotter than the surrounding natural ecosystems. So our question is this: how can we leverage our STEM and art skills to solve this seemingly monumental problem?
And our answer was to engineer a heat-fighting microsphere paint made out of barium sulfate microspheres. And the thing about this paint is it not only reflects very, very well, nearly 99.7% of incoming light is reflected back out, it does so at a wavelength called the atmospheric window, which means all the light goes clean through the atmosphere and out into space. And what we're going to do with this paint is we're going to create a mural. This is the sketch of our mural, and we're going to, this mural is going to be at our local science museum called the Wonder Lab. But first, we're going to talk about how we created this paint. So in order to make this paint, we combined a barium chloride and sodium sulfate solution to create our barium sulfate microspheres. We chose these two chemicals perfectly, or we chose these chemicals with a lot of care to make sure that our byproduct was going to be an easily disposable and harmless byproduct, salt water, instead of something that is hazardous and toxic for the environment, like hydrochloric acid. So this reaction was performed at 4 different temperatures, which means we will also get 4 different sizes of microspheres. And when combined, they undergo a process called densification, which basically packs in all of the paint particles so that the paint can cool very, very well. And then we took this solution and put it in a centrifuge in order to separate the barium sulfate microspheres from the saltwater solution. Afterwards, we loaded the barium sulfate and combined it with a binding agent, dimethylformamide, and also an acrylic, polymethyl methacrylate, to create our paint.
So after we made the paint, we had to test it. Using reclaimed materials from old construction sites and classrooms, we painted a variety of substances from cardboard to limestone to wood for durability and efficacy. And we also, using a team member's personal scanning electron microscope, took images at 10,000x to ensure correct microsphere formation. But of course, the most important test of all was seeing if it actually mitigated urban heat islands. And so with the thermal camera, we saw up to 6 degrees of cooling, which you'll see in our prototype later.
Our local community is very excited by our work as well. We were able to present our project through to a climate workshop through Indiana University. And we've been working closely with the city of Bloomington to find an impactful location for our mural. With their help, we decided on the Wonder Lab, which is a local youth science museum. The Wonder Lab is located in the heart of our city. So it will be visible to the nearly 2 million annual tourists we receive. And also at the Wonder Lab, we'll be able to teach climate lessons to the students. There are almost 20,000 that go there every year. Around the world, public art is used to inspire communities and raise awareness for causes. And we really hope our mural can do this as well.
Yeah, and then from a practical standpoint, this is barium sulfate paint, so it will cool the building it's attached to radiatively, passively, eating into the over half a billion tons of greenhouse gas emissions emitted by the air conditioning industry each year. So once again, here's a final reminder. This is the sketch of our mural and a very excited kid. We hope you're as excited as this little kid about this project, because we sure are. Thank you. And now, yeah.
And then our demo's very passive, so we're going to do it while we answer questions. And we have a thermal camera, so we'll be able to see the difference between regular acrylic white paint and then our barium sulfate paint.
I'm curious whether you've looked at other paints that actually conduct or perform the same sort of heat reflection, and if so, is this a cheaper or more expensive option?
Sure. So this is on the more expensive side, but this is the most effective white paint. Normal white paint reflects maybe 80%. Super reflective white paints maybe get to 85 or 90. Ours gets to 99.7% of sunlight reflected.
Are there any special application or cleanup techniques?
No, it applies almost exactly like normal white paint. You just have to use a couple extra coats to really make sure that the entire surface is covered.
And then I have a follow-up. What is the price difference?
Sure. So the price of normal white paint can range anywhere from $20 to $70. Ours is about $180 a gallon. But the interesting part about this is we've talked to researchers, Alix Kingston from the Utah State University, and if you mix this paint with regular white paint, you still achieve 95, 97% reflectivity. So that's a way to mitigate costs.
And then, so your immediate kind of impact is the mural. What would you hope to do kind of future facing?
So a big part of our project, again, is just to raise awareness for climate change in our community. So our mural being visible, it's located actually on a trail in Bloomington that's used by many, many people. It's called the Beeline Trail. They recently expanded it. And then also at the Wonder Lab, we hope to teach climate lessons to the students. And then again, this is an innovative paint that people don't see very often, so it being in such a public place raises awareness for it to be used in larger scale events.
And does it cool in the building as well as outside the building, or?
Yeah, so by reflecting so much sunlight from outside the building, it reduces the need for air conditioning inside the building because the building absorbs less heat, and as such, the inside is colder. And so now Rebecca's going to take a picture, and then I'm sure you guys can see it on the phone.
So currently, you're looking at doing that as a art for art. With
Right.
Have you considered, like the lines in the street or
Yeah,
parking
yeah.
lots and roofs, maybe?
Of course. So over 50% of Bloomington roofs right now are not white, right? And that's like a big area for improvement. And using this paint can help maximize the white roof solution. And then on top of that, it can be used to paint automobiles, houses, anything you can imagine. It functions as a more reflective, more environmentally friendly paint. Here you can see.
So this is a picture of of our white paint and normal white paint under the thermal camera, and the thermal camera has a little bit of an offset. So this is commercial white paint, and then there's a very bright strip where there's no paint at all, and then this is our paint. And you can see there is a difference.
And we find it ranges anywhere from 6 to 11 degrees of temperature difference, depending on material and time of day and stuff like that. And of course, this isn't perfectly the sun, so,
Is it stored any differently?
No, it stores very well, very similar to regular paint. The only thing is before you use it, you have to mix it, but that's pretty standard with paints.
And is it only white?
Yeah, the barium sulfate is an
Yeah.
ultra white, so it's white only.
Any final questions from our judges? All right, thank you.
Thank you, guys.
High School South.
Angie, I feel like I've been in DC too long. I saw the formula with the elements in it, and I thought it was a list of government agencies.
Yeah, you've definitely been in DC too long.
I think this is not a good thing.
Yeah. But speaking of DC, had you ever heard of an urban heat island before?
I mean, DC is an urban heat island.
Yeah.
There's a whole section of the city called Foggy Bottom for a reason. It's really not a great city, but they got it for cheap. Yeah.
Yeah. I had never heard that term before. So even me being from New York, living in a city where it gets very hot, I learn something new every day in this job. So.
Absolutely.
All right, let's welcome to the stage Richmond Hill Middle School from Richmond Hill, Georgia.
Ew, we're distributing props right away. I like it.
Good afternoon, esteemed members of the panel. My name is Jessica Boys. This is Gabby Mondesir, and we're from Richmond Hill Middle School.
Nightmares. No, we're not talking about lucid fever dreams or the dreams where you're being chased by the monster from your closet.
We're talking about a much more frightening phenomenon that occurs in the comfort of one's own bed.
Night terrors. This commonly occurs in those struggling with post-traumatic stress disorder.
We estimated that about 60 people would be in this room to watch us present. Of those 60 people, 4 would likely suffer from PTSD.
Unfortunately, around 6% of the general population will be affected by PTSD.
Although this number may seem small from a generalized perspective, this is estimated to be roughly 354 million people worldwide.
While there is no definite cure for PTSD, there are many treatments. One of those treatments being our prototype, Safe Sleep.
While defining our problem, we identified an issue commonly associated with our community. This issue being that many members suffer from PTSD, which in turn causes struggles with sleep.
Safe Sleep directly impacts our community as we have 2 military bases in our area, those being Fort Stewart and Hunter Army Airfield.
In addition to the bases, just over 31% of students at our middle school have a parent or guardian actively serving in the U.S. Armed Forces.
Solving this issue came with a lot of much-needed research about PTSD.
We had to understand PTSD, its causes, impact, and symptoms. A traumatic event occurring can often result in a person developing PTSD. Symptoms of PTSD include recurring or intrusive memories, reliving past events, severe emotional distress, and lastly, our focus today, night terrors.
After researching PTSD, we shifted our focus to analyzing current solutions to aid those affected by it.
During the design
Our team has had the opportunity to speak with various community experts, including Major Kyle Head, a retired veteran who suffers from PTSD, and Nicole Mondesir, a social worker for the Department of the Army and Department of Defense.
We spoke with them both to find out what could be triggering for certain people and what could calm a person down. During the design solution phase of the project, we came up with our concept. Safe Sleep is a device that someone with PTSD wears at night in the form of a wristband.
The device uses a heart rate monitor to track the heart rate of the wearer. If the monitor picks up a heart rate over 100 beats per minute, it will alert the companion app to begin a set of programmed breathing exercises. Build and test was a crucial step in our design process, as this was when we received our final feedback from our community partners.
Additionally, during this phase, we tested many different ways of communicating with our companion app. As you can see in the flowchart, the device will go off when a set heart rate is reached. The user will have the option to click a button if it was a false alarm.
If the button indicating it was not a false alarm is not clicked, the app will play a set of programmed breathing exercises. Once the breathing exercises are complete, the user will input how they are feeling. If their user inputs below a 5, breathing exercises will repeat as needed. However, if the user inputs a 5 or above, the user will hopefully go back to sleep.
We use minimal electrical components, which in turn preserves precious metals.
Okay. We use a C-Tweeter microprocessor, Bluetooth module, and heart rate sensor to keep the device as minimally invasive as possible while still remaining functional.
So, as I said before, we use minimal electrical components, which in turn preserves precious metals.
Therefore, there will be less need for mining said precious metals for these components. Therefore, less habitats will be destroyed and deforestation can be minimized significantly.
Because forests would be able to grow healthily, the oxygen being produced by trees would combat carbon dioxide being released into air.
The data we collected suggests that 92% of those surveyed said they would use Safe Sleep, and 100% of our participants said that Safe Sleep could help them or someone else they know who struggles with PTSD.
Our goal with Safe Sleep is to create a space in which survivors of PTSD not only live happier, healthier lives, but also have better sleep quality.
We hope that with Safe Sleep, survivors of PTSD know that with Safe Sleep, they can sleep easy.
Nice job, guys. I love how you implemented the engineering design cycle. Tell us a little bit about, have you done any user testing so far?
We have not tested on community partners. However, we have tested on ourselves to make sure that not only the sensor works, but also our app works.
Thank you.
How does the app wake you up?
So essentially when someone's having a night terror, it's almost as if they're having a panic attack. So essentially they'd already be awake. So the app would simply calm them down from a panic attack so they're able to go back to sleep. So essentially the app isn't waking them up, it's more so helping them go back to sleep. Because when you're having a night terror, it's kind of like the same state as a panic attack, so you're already awake essentially.
So you worked with a couple of individuals that actually have PTSD of night terrors, like I think Major Head was one of them. How does he cope with night terrors? What does he do to try to remedy it without your device and his adoption? What would it take for him to adopt this device?
While speaking with him, he said that he gets on average around 4 hours of sleep, and around 2 a.m. he'll start waking up in cycles. So he never had something to cope before this device.
I wasn't sure if I missed it. Did you show that the device tracks anything, or is there data that's collected over time?
As we're still working on the app, there isn't something that tracks it, but we are planning on having something that tracks sleep.
I think in your video you talked about some other ideas you had rather than just the breathing exercises. Can you talk through what some of those other options were?
So originally we decided that we might wanted to have a calming noise or a scent diffuser. However, we discovered that certain scents could be triggering. So around the design phase, this is when we cycled back over and over again, reevaluating what could be successful, what could trigger a person, and what could help a person. So that's when we spoke with, for instance, Nicole Montesir and found solutions that would be more practical. For instance, breathing exercises, which are commonly used by the Department of Defense. There are already certain treatments around that use this technique, and we found through studies that it's more practical in helping PTSD rather than with certain scents or noises, which can often be triggering.
And are those exercises delivered through the phone then, or how does that work?
Yes, they're delivered through the app. So essentially, we have different kinds of breathing exercises that the user can, the user will select which option they want depending on their personal preference.
All right, any more questions from our judges? All right, thank you, Richmond Hill. Kevin, I'm so impressed with just the breadth of solutions that we're seeing. We've got mental health, public safety, climate change, just so much depth of knowledge of these kids and of their solutions. It shows that they're really paying attention to what's going on in their community. And
Absolutely.
It's really inspiring.
No, and it's really interesting to see as we kind of move across the country with all the schools here, the differences and the challenges that we see in each of these individual communities and their ways of addressing it.
All right, let's welcome our next school, Santa Teresa High School from New Mexico.
Got it?
Very good afternoon. Muy buenas tardes. My name is Erica, and these are my teammates, Jake and Lluvia. How often do you guys walk outside on the coldest night of the year, barefoot? Probably not too often, for obvious reasons. Depicted in the image is a little girl named Brenda. She is in fact shown barefoot, as you guys may see. She is one of the people who are homeless on our streets back at home. She is one out of thousands of asylum seekers made up of families and children especially, who are prone to cold-related illnesses due to exposure to extreme temperatures. Having vulnerable people on your streets doesn't make it easy for any community, and being able to aid them is not only difficult, but costly. That is why we decided to create something to help assess the situation. We like to call it the Living Lumbre. Its goal is to be able to aid this group of people with providing a source that can help them ensure their well-being, their overall well-being. The same goal is depicted in our logo, which depicts a flame inside a heart, representing the hope and the light these people need.
Living Lumbre is a solar-powered heating mat. However, not a mat that heats up when in contact with the sun. Instead, it charges a battery, allowing for the users to use the mat whenever they wish. Living Lumbre was made so that people could have safety and warmth, and this would greatly impact their health. Now, we made this using materials such as a heavy-duty tarp, polyester, carbon fiber heating coil, and a mylar blanket. This would radiate their own body heat. Now, we really made this with the people back at home's heart at mind. So that is why we included features such as a temperature controller, temperature monitor, and a GPS locator.
To further elaborate on the features listed, Living Lumbre's main functionality is driven by a microcontroller, which is also a microprocessor. This microcontroller not only incorporates a built-in temperature monitor, which allows for continuous temperature, for collecting continuous temperature, but we also integrated a GPS module to know precise location. One of the main ideas behind having a GPS location is to keep track of Living Lumbre. And we also, the main idea behind having a GPS location was to incorporate maintenance to make it more sustainable, because Living Lumbre uses renewable energy, but we thought that that wasn't really enough for sustainability. Last but not least is Living Lumbre's application, which relays the user's temperature preferences to the microcontroller, which allows the user to control the temperature. As we look to the future, our vision includes incorporating a heart rate monitor to ensure the user's heart rate is normal, as well as a panic button the user can use to notify emergency services, ensuring that help is just a touch away. Last but not least is a pressure sensor that will help determine if Living Lumbre is currently being used. Ultimately, the data collected by Living Lumbre not only has the potential to save lives, but it serves an impact that goes beyond comfort and convenience.
With Living Lumbre, users will be able to have access to a resource that will help them ensure health security. Not only that, but through artificial intelligence, city governments and organizations will be able to monitor and access data to make better predictions on how to help these people. The best part is that Living Lumbre can benefit communities all over the country, not just ours. Our goal is that we can create a firm foundation and a foundation of hope for all of those who need it. Thank you. Do you guys have any questions?
What's the estimated cost?
The estimated cost is around $70.
So do you envision like a city government paying for these, or where do you think the funding would come from?
So there's many possibilities to where it can go to, specifically in our community. There's shelters, there's rescue missions. Not only that, there's a lot of churches that are helping. So there's many, many organizations that we can get involved with. They've already been really involved with many resources to helping. So we know this would be one that would be tremendously helpful for their mission.
I would like to add on to that, and we expect the average price to go down as mass production begins. So that's also another thing.
So I can see applications for this for hikers and backpackers and just people who want to be outdoors by choice as well. But how long will it keep stay warm? How long will it stay warm with one charge?
We researched this, and the battery will last around 9 hours. So that's typically how much a person would get of sleep usually. So we believe that that is a good amount for it to stay warm, especially if they're going to use it all night when they're sleeping.
I have a question about the long-term disposal of this. So once it's used by one or two people, where would you plan to dispose of this material and dispose of the living loubre?
Okay, that's a really, really good question. So I did mention that the main use for the GPS was to actually, well, it's mainly for people who are homeless, right, and they don't have homes. So their main, I guess you could say, like, people of interest would be government supplying this. So they can use that GPS to then track the mats and then take the mats and then assess them and then do maintenance and then send them back out again. So that way they're not just there and then they're just left wasted, because this material is not recycled. But hopefully in the future we do incorporate material that is recyclable, like plastics that will be heavy duty and like waterproof and stuff like that.
Have you all looked at the durability of the materials? Like, how long do you think someone using this every single night, how long do you think that it would last?
Yeah, so we did keep that in mind a lot when creating this. Right now we use the heavy duty tarp. Obviously it works really against rugged materials, hard surfaces, it's waterproof, and it's really durable. So it's gonna help protect all the inside, its durability. We created layers with Mylar. That's all gonna help serve its cause. Any other questions?
I think you all did an very interesting project, and all the questions asked were kind of the direction I was going. So production, like, to scale, what does it look like if you were to scale this out? How many do you think you'd produce of this, and where do you think you would be spending the most of the effort in that?
Well, like we said, for our community specifically, this is directed for, obviously, migration, asylum seekers, refugees. But this can turn to something a lot bigger, just homeless overall, unhoused veterans. We even got the idea from people in our community saying, hey, this can be used for the army. Hey, this can be used for survival and camping. So this can go big, really big. This is specifically what's going towards our community, but yes, it can be marketed into a lot.
To kind of answer the other half of your question, it doesn't really take a lot because it's just kind of layers that right now it's Velcro that's holding it together, right? So preferably you just spray adhesive and you glue the layers together. So for mass production, it's not going to be like this whole like assembly line going on, because you just kind of lay down the layers and you put the coil, then you put the last layer and you're kind of set. So it shouldn't take long to mass produce this type of mat.
Any last questions? All right, thank you, Santa Teresa High School from New Mexico. Do you guys want the table up or back? Back, okay. We gotta move the table.
They didn't mention that furniture moving was part of this job description.
Part of the
but
gig,
this is,
part of the gig. Yeah. Kevin, have you ever heard the term stempathy?
I have now.
It's what we talk about as part of Solve for Tomorrow. It's using it's putting yourself in someone else's shoes and then using STEM to solve some of the problems that they might be facing. And I think that was a great example of STEMpathy at play.
Absolutely.
All right, our next team is Merrimack Valley High School from New Hampshire.
We are from Merrimack Valley High School in Pennacook, New Hampshire. This is Alyssa Ishii, Rihanna Devone, and I'm Kelly Bentley. For our project, we designed and prototyped a phosphorus filtering robot. In our community, the Merrimack River is very important to us. Historically, it has provided communication, transportation, and resources, and today it provides electricity and drinking water. But unfortunately, the river experiences water pollution and excess levels of nutrients like phosphorus. Phosphorus causes a cyanobacteria, which is a blue-green algae that can be harmful to humans in way of skin rashes, irritating the nose, throat, and eyes, and damaging the liver and nervous system if ingested. This is where Shelby comes in. When Shelby traverses the local Merrimack River and nearby bodies of water, she provides safer drinking water, increased levels of oxygen, reduced algae bloom, and promotes plant and animal life. And Shelby is our phosphorus filtering robot that filters phosphorus.
So Shelby produces extremely low gas emissions, and in the future it'll be even lower when she's solar powered. And she functions by the water first filtering through the foam phosphate layer that surrounds her body, and then through the application of chemistry, the bagged resin inside precipitates the phosphorus out with the addition of calcium, iron, and aluminum salts. And she's powered by a small lead battery that allows her to traverse waters via DC motors and a controller. And we learned to solder electronics in order to connect the controller to the motors. And her shell here is made of fully recycled material that is made to blend in with her surroundings, and the PVC piping that her main structure is made of is also fully recyclable.
All right, so to design Shelby, first we researched about the problem and we spoke to a local expert at the New Hampshire Department of Environmental Services. And after brainstorming a solution, we began prototyping and assembling Shelby. And after making some redesigns and making some necessary changes, we modeled Shelby in a 3D modeling software, and then we began our trials. And so this is just a quick clip of Shelby in action. If you could play the video, please. Yeah. Yeah. And so for the results of our trials, we conducted 2 of them, and those consisted of placing Shelby in a tank, a 40-gallon tank full of water, and 3/4 grams of phosphorus added in order to simulate the conditions of the Merrimack River. And so we left Shelby active. We left her swimming around in there at 20-minute intervals, and we measured the absorbance of the water with a colorimeter at each 20-minute interval. And what absorbance measures is how much light a material can absorb. So low levels of absorbance corresponds to low levels of phosphorus because pure water can absorb less than dirty water. And both of our trials showed a very significant decrease in absorbance as Shelby was active, indicating that Shelby was indeed effective at filtering phosphorus out of the water. So in the future, as previously mentioned, we want to move away from the lead battery and transition to solar panels for increased sustainability. And we want to have Shelby move autonomously and eliminate a wired controller so that Shelby can function with minimal human involvement. And incorporating the GPS sensor so Shelby can route home on her own when needed would also be something that we would like to do. And to further expand upon our current filtration system, we would like to implement a semi-permeable membrane so suspended solids could be filtered out of the water before Shelby begins her work. And another filtration system we experimented with and did work on was using lime tablets. So when lime tablets react with water,
that creates a chemical reaction, and calcium sulfate, an inert precipitate, is formed, and that can be contained while clean water is expelled out, which is another thing we'd like to experiment with. And yeah, so thank you so much for listening to our presentation.
So you did your testing in a tank. Tell us a little bit about how long would it take for Shelby to actually make its way through the Merrimack River, and then is there a potential that you would have multiple?
Right, so yes, we did test Shelby in a tank, and as you can see the time intervals, it took around 40 to 100 minutes for the water in that contained area to become clean. But if we were to implement Shelby in the actual river, we'd probably have a bigger size, for one thing. And a solution we came up with was attaching Shelby also to boats. So, that could be passive transportation of Shelby. And as the boat would travel up and down the Merrimack River, that would be the water would be passively clean that way.
So there are some unique challenges to deploying a filtration system in a moving body of water. What challenges did you predict, and how did you deal with those challenges?
Do you want to go ahead? Yeah. So, of course, the major challenges we anticipated, first of all, was just like the speed of the water, for one thing, and how such a harsh force, that water could impact, our robot. And so that's where the idea of attaching it to a moving boat comes in as well. The boat would provide some sort of, protection and all that. And every body of water is different, is another thing. Each body of water has different needs, and those would have to be adjusted based on what body of water it's being deployed in.
In addition to this, we've had multiple people contact us to be able to deploy Shelby in a pond or a lake, so there's obviously a lot less movement because there's not a current that would pull her. But in the future, if she has the Lime tablet, it'll be a lot more sustainable, a lot less human interaction will be necessary because of a different filtration system.
I'm very curious, how'd you come up with the name Shelby?
Well, she's a turtle. She has a shell, and we thought that Shelby would be very cute. So that was our naming. Thank you.
Follow-up question. What happens to the phosphorus? Where does it go?
Yeah, so the phosphorus remains trapped in those filters and formed in that precipitate and in that bagged resin. Mm-hmm.
How often do you foresee, in the case that you have, replacing the chemical reagent?
Right, of course. So yeah, as we said previously, the Shelby cannot function totally without human involvement. Of course, people will need to replace the filters, and so after every period that she is active in, after every circuit that a boat were to complete, for example, or however long Shelby's battery life would last, would be when filters and bagged resin would be replaced for optimal functioning.
So in that case, you're thinking that the resin would last for the entire charge of the battery?
Yes.
Any final questions from our judges? All right, thank you, Merrimack Valley. That was great.
I think it would take a lot of Shelbys to clean up the Potomac, but
Yeah.
Get to work here. You've got your challenge ahead of you here
Yeah.
in DC.
Maybe they can make them bigger.
A little bit bigger.
Yeah. All right, we are, what's that? Oh.
More furniture moving.
Yes, more furniture.
There we go. If anybody's looking for movers after the show, please let us know. We'll be available.
All right, coming to the stage now, we have Strawberry Crest High School from Florida.
All right, and I'd like a special round of applause because they get to be the very last presentation. So there we go.
So you need both ones.
This is a very interactive presentation. I like it.
Hi, my name is Anna Steed.
I'm Patrick Say.
And I'm Mehar Chabra.
And we are students from Strawberry Crest High School. For our project, we built and designed a wearable device that monitors the temperature of athletes during conditioning and games. Once we built the prototype, we then developed an app that receives the temperature data from the device and relays this information to coaches and trainers, allowing coaches to identify athletes who are at risk of developing a heat-related illness.
Football is one of America's favorite sports, but it is also the sport with the highest number of heat-related deaths in the United States. According to studies, football players are 11 times more likely to develop a heat-related illness than all other sports combined. This slide is in honor and memory of student athletes who have lost their lives to heat-related illnesses. A survey we conducted in our community found that 1 in 5 families have been impacted by this serious problem. Saving the lives of student athletes in our community is the #1 goal of this project. And to do this, we needed to use STEM.
So the development of this device was not without challenges. We started with an Arduino Uno board, but needed to switch to a breadboard in order to be able to use the Nano RP2040, which allows for Bluetooth connectivity to the app. We also needed to develop a way to power the device while on the athlete. Since our original submission video, we've added a vibration motor. This was at the recommendation of the director of an athletic training program at a university. Now the athlete will receive a direct warning via vibration if the temperature is unsafe. Once we completed the prototype, we switched our focus to the software. The sensors were coded in Arduino IDE, and the app was coded using Flutter. One of our peers, Varun Patel, used his coding experience to teach our team how to develop the software we needed to bring our project to life.
In the making of our project, we took sustainability into consideration through the following methods. First, we use a rechargeable lithium-ion battery to conserve energy and make the product long-lasting. Second, we use recycled fabric to secure the hardware to the football gear. And lastly, our band was designed to be used in multiple sports throughout the year and in various conditions.
We'd like to take a minute to show you our project in action. So we researched the correlation between skin and core body temperature to implement into our code, but for demonstration purposes, the threshold has been lowered to 76 degrees Fahrenheit for the temperature sensor and 75 degrees Fahrenheit for the vibration motor to operate. So if you could just rub your hands together over the temperature sensor, just holding the temperature sensor, and we can see the information relayed to the phone. And in a minute, an alarm will go off, and you'll feel the vibration. And if we can't get it there, we have hot hands. A little bit higher. So as you can see, this device ensures that the athlete and the coach can both respond in a timely manner, and this will prevent heat-related illnesses from becoming serious and life-threatening by being able to prevent them early on. Thank you. Right. Yeah.
All right, do you guys have any
questions?
So how much does something like this cost?
So our device right now is at $45, which is considerably cheaper than all of the other options that we have on the market. And with the help of another company that can help us and give us funding and bring this project to life, we can lower the cost even more. And we have a bulky prototype right now, but with the help of another company, we can bring that size down a lot slimmer, and we wouldn't even need to have a device that sits on the pads. We can have everything on the singular band, which allows it to be used in any other sports any industries, anybody could use it without having to deal with the hassle of the wires, and it would also be a lot cheaper.
How durable is it right now? I mean, is it going to get damaged, like actually playing football, or?
So right now we have it in this foam protective covering within our reusable fabric pouch, and that is secured behind the football pads against the player's chest. So as of right now, it is durable, but we fear that a strong impact could be damaging to either the player or the device. So down the line, downsizing the device would be a great accomplishment.
And have you tested it with your football team at school?
So right now we have not tested it actually like in action with the players. We've only tested it, within the classroom and then just like doing simple exercises to monitor the heat. But in the future, we would definitely like to implement it with our own school's football team and then branch out to other football teams as well.
Was there consideration to use it for the opposite directions for like hypothermia as opposed to hyperthermia?
We hadn't really thought about that. I think that's a really interesting question. The device itself just monitors temperature, so it would be very easy for us to set the threshold to whatever temperature we require. And so instead of monitoring heat, like it being like the temperature going off when it's extremely high, it might be possible to set it to where it's lower.
That's a very good question. Yeah.
So right now you're measuring body temperature, and that information is shared with coaches. Who else would it be helpful to be sharing that information with?
Yeah, so coaches and as well as the athletic trainers, they will have the app on their phones during the games or whatever other situation they're trying to monitor. So that'll be helpful for them to just monitor the health of their team as a whole and also share it with the parents or the medics or anyone else that might be involved if there's an issue.
And the vibration motor going off a degree before the alarm on the app goes off means that the athlete also receives a warning that their temperature has been too high and they need to come off the field. So everybody who is involved in the game knows and is aware of the fact that their temperature has risen too high and they need to be taken off the field.
And in addition to football and sports, our community has told us that it would be a great this would be a great option for groups like ROTC or marching band who experience the same hot climate but don't have the same protection.
What's the transmission range on your device? How far can the signal travel from the person with the app?
So right now we have a Bluetooth device implemented in this, and so that would be something where everyone within the range of the field would be able to receive data, but we hope in the future that we would be able to use a Wi-Fi hub so more players can connect and the connection would be stronger and where transmission wouldn't be an issue.
Make sure it's waterproof.
All right, any final questions from our judges? All right, thank you, Strawberry Crest.
Thank you.
Let's move this back to the middle. All right. Wow, you guys, what a day. I mean, we have seen 10 amazing projects that focus on science, technology, engineering, and math to address head-on some of the issues that we are all facing in our communities. And I gotta say, I mentioned in the beginning that I was new to the Solve for Tomorrow family, and everyone was like, this is the best day of the year. And now I get it. This was such a fun experience. It was so great to see all of you come up here, shake off the nerves, answer tough questions from our judges, and present your solutions so beautifully. And I have to say that one of my favorite parts of being up here was I got to watch the reactions of all of the teachers. And it was really great to see the looks of pride on your face when you saw your groups get up here. So big round of applause for all of the teachers. And definitely big, big congratulations and another round of applause for all of our students. And finally, a round of applause for our judges.
Angie, I was going to say there are at least 5 people in this room for whom it's probably not the best day. So thank you all. You have a very tough decision to make after those great presentations. So everybody, we will be back tomorrow here at 8:30 a.m. So for those of you on Mountain and Central Time, I'm sorry, but we look forward to seeing you. And everybody, thank you so much for joining us in DC. I will not be on stage tomorrow. I'll be back with you, which is a much better side of the mic to be on. But thank you for being here, and we look forward to seeing you tomorrow morning.
Yes, but now we celebrate. We have some great things in store for all of you here, and make sure you tune in tomorrow on the live stream as we continue the celebration and announce our winners and give out some more special awards. So thank you, everyone.